Hello class, today we're going to talk about section 3.2, which is solving linear equations by graphing. By the end of today's lesson, you will be able to find the root of a linear equation using a graph, and you will be able to find the root algebraically. A couple of more facts to talk about with linear equations and functions. First one is the parent function. This is what we call the most basic function that is a linear equation. If we write it out in a more recognizable form, it would say y is equal to x. Remember that f of x is a symbol for function notation, but it's telling you the same thing. The domain of a linear function is asking you what x values you can plug in. If you're looking and you're thinking about it, there is no limit to what we can plug in for x, so we're going to say that we can have all real numbers. Yes, there are imaginary numbers, and no, you do not need to worry about them until Algebra 2. So, a linear function allows you to plug in all real numbers. If you don't want to write out all real numbers, you can use the symbol, which is a capital R, with a line through it. The other thing we need to think about is the range values. So those are all the y values we could possibly get as answers. If you think about a line on the graph, it extends in both directions forever and ever, meaning that it could reach any y that we want. So the range of a linear function is also all real numbers. Last thing we need to talk about is the root. That is the values of x, where f of x is equal to 0. Or if we put that in that more standard notation, where we get an answer of y is equal to 0. This can also be called the x-intercept. We talked about that last section. That was the x comma 0, so that y value is equal to 0. It can also be called the zero of the equation, and it is most commonly referred to as the solution of the equation. So those four words are interchangeable. Your book will use them interchangeably. I will most likely call it the x-intercept or the solution, but your book in this section focuses on calling it the root. So, to find the root graphically, the first thing that we need to do is we need to get the equation set equal to 0. Again, as it said, the f of x has to equal 0, so we have to get our equation to equal 0. One quick step to do that, add 2 to both sides, and we end up with 4x plus 4 is equal to 0. What that 0 tells us is that we are looking at that x-axis right there. So we're looking at that middle line. The next thing that we have to do is we have to put some points on the graph. Remember, in order to have a line, we need at least 2 points. We have to have one positive answer and one negative answer because we need our line to cross over that green line that I drew in. So, one easy point to check would be to plug in 1. So 4 times 1 is 4, plus 4 gives us 8. So when I plugged in 1 for x, I got an answer of 8. Now I want to try and get out a negative answer. So I'm going to try plugging in a negative. I'm going to pick out a negative 2. So 4 times negative 2 gives us negative 8 plus 4, which gives me a negative 4. So that first point we plugged in 1, and we got an answer of 8. The second one we plugged in negative 2, and we got an answer of negative 4. So I'm going to put that on the graph as well. Then we have to go through and connect our points. Again, remember, when you are making a line on the graph, you should be using a straight edge and going all the way through the entirety of the graph through those points that you picked. You should have it all the way through, and there should be those arrows on the end. So what we are looking for here is the root, or where it crossed that green line. If we're looking close, we end up right about there. So we're going to say x is about equal to negative 1. That would roughly be the solution for our graph. Now, because it's graphing, it might not be totally accurate. You might have gotten negative 1/2 or negative 1.5, so there might have been a little leeway in there. That's why we use that approximately equal, or that squiggle sign, to indicate that we graphed, so it's not an exact answer. Go ahead and try this one on your own. So for x values, I picked -4 to start, giving me that -2 red point down here, and then I picked +1, giving me an answer of 8 up top. When I look at where it crosses at x is approximately equal to -3. If you have questions about the graphing, please let me know when you get to class. Our next option is to solve algebraically, which is just another way of saying solve the equation. So we're going to follow our SAD meet steps. First, we're going to take away 6 to get rid of that addition, so I end up with 2/5 x is equal to -6. If you remember, to get rid of a fraction, we are multiplying by the reciprocal of that fraction, so we are multiplying by 5/2. Those cancel out, and we end up with -30/2. When we simplify that, that gives us an answer of x is equal to -15. Remember on the first slide, and up top we can see that it's supposed to equal 0. If you want to double check, you can do 2/5 times -15 plus 6. 2 times -15 is -30 divided by 5 gives you -6 plus 6, which does equal 0, so it checks out. Go ahead and try to solve this one on your own. You should have gotten an answer of x is equal to 9. If you have questions about that one, please let me know. The last two examples we're going to talk about are two special cases we have when we are trying to find the solution to an equation. So, our goal is to try and get the equation equal to 0. So the first thing I'm going to do is move that 4 over to the other side. So I end up with an answer of 2x plus 7 is equal to 2x. We're still not equal to 0, so I'm going to move that 2x over to the other side, and we end up with an answer of 7 is equal to 0. So what this is really saying is that we have y is equal to 0 and y is equal to 7. When you put that on that graph, that y is equal to 0 is the same that we had in those first two graphing problems that we looked at. It's that center line. The second one of y is equal to 7 is telling me that I've got all of those y values up top. Any x, all of those y values are 7. If you notice, the red line never touches the green line. So this would be a way that we could identify no solution if you're putting it on a graph. If you just solved it algebraically, you could have stopped right here and said this is false, which again would indicate no solution. So that's what no solution looks like on a graph and what it would look like algebraically. On the flip side of no solution, we have something called all solutions. Again, we are trying to get the equation to equal 0, so I take 6 away from both sides, and I end up with 3x is equal to 3x. Solving to 0, take the 3 away from both sides, and I end up with 0 is equal to 0. So what we have here is that y is equal to 0 and y is equal to 0. So that first line is the same as it's been in all of the other problems, and that second line that it gives us is the same one right over the top. So then, since they are stacked up or touching each other at all points, we call this all solutions, because our line touches that green line at all of the possible x values. If you were looking at it algebraically, you could have stopped here when you had 0 is equal to 0. You could have stopped here when you had 3x is equal to 3x. Or you did not even have to solve the problem, because you can notice that both sides of the equation are equal, telling you that it's all solutions. That would have worked back way at the top of this first equation for no solutions. If you have the same x values with different y values, that will indicate that it is a no solution situation. If you have questions about this or anything else we covered in the lesson, please let me know when you get to class.